Hello, in this video I will be going over voltaic cells so that you can master them in AP chemistry. Voltaic cells, or galvanic cells, are spontaneous electrochemical cells which use redox reactions to generate electricity. Composed of two half cells and a salt bridge, the voltage generated is always positive due to the reaction being spontaneous. With the cathode and anode each making up half of the reaction, oxidation and reduction can occur. Now we will go over the main parts of a voltaic cell. This is the anode, which is where oxidation occurs. On the right is the cathode, where reduction occurs. At the top is the voltmeter, which measures the amounts of volts generated. And in the middle is the salt bridge, which allows for the transfer of ions between the two half cells. In this example of a voltaic cell, electrons are transferred from the anode to the cathode, as the oxidation and reduction reactions are taking place, and the salt bridge allows for electric neutrality. This transfer of electrons causes the anode, left, to lose mass, and the cathode, right, to gain mass. As the solid zinc loses electrons, it disperses into aqueous zinc 2+, and the copper 2+ joins with the electrons to form solid copper. Because of this, the mass of the anode decreases as the electrode loses mass because the zinc dissolves into the aqueous solution. A salt bridge is one of the three main components in a voltaic cell and is used to connect the oxidation and reduction half cells of a voltaic cell. It maintains electric neutrality within the internal circuit by providing ions to the solutions in order to maintain ionic neutrality. When charges are lost during electron transfers, ions from the salt bridge are used to replace it, allowing for electric neutrality to be maintained. A voltmeter measures the electricity generated and is a positive value to signify that it is spontaneous. In order to find the electrochemical cell potentials, use the reduction potentials of the cathode minus reduction potentials of the anode, which results in a measure in volts. This value will always be positive for a voltaic cell. To create a cell diagram, write out the two half-cell reactions and determine which is the anode and which is the cathode. The anode is at the left and the cathode is at the right. Oxidation occurs at the anode, while reduction occurs at the cathode, and the salt bridge is in the middle. This picture shows the difference between a galvanic and electrolytic cell. While both cells are composed of the main three parts of an anode, cathode, and salt bridge, galvanic cells are spontaneous, while electrolytic cells are not, which is what is the defining difference between these two different cells. This image shows a commercial galvanic cell, which is still composed of the three main key parts of an anode, a cathode, and a salt bridge, and performs just as any other voltaic cell would. Voltage is the potential difference between two half cells and the amount of energy that drives the reaction. Current is the flow of electric charges. Primary batteries are non-rechargeable batteries, secondary batteries are rechargeable batteries, and tertiary batteries are fuel cells. Voltaic cells are composed of two half cells at which oxidation and reduction occur. A salt bridge maintains electric neutrality and allows for the flow of ions, and the anode's mass decreases while the cathode's increases. These reactions are spontaneous, which results in a positive E cell, and cell diagrams are formed using the half-cell reaction.